Welcome back to the Niner Nation podcast. We are here in 2026. I'm your host, Evan Nazareth, and today I'm joined by Gavin Kelley, who is a senior electrical engineering / physics major, who is also doing early entry for electrical engineering as well. Today, we will see his electrons function as he tries to answer my questions for today. So, Gavin, what's your take on astrology?
Wow, okay. I came prepared with a few typical questions. This wasn't not on the list. This was not on the list you gave me, right?
Yeah.
No. Do you want my science answer or my person answer? Okay, let me phrase it this way. Do you want my actual answer or the answer that I would give you at the bar?
I'll take both.
Okay. Let's start with the bar answer. It's I would say something along the lines of, oh, that's just really not for me. And I would be politeful because usually when people ask that, they're
kind of thinking about certain things.
Yeah, they probably like that stuff, right?
Yeah.
Well, I don't have a problem with that. I don't have a problem if someone likes that stuff. Typically, it's not for me. Okay, that's my at the bar, trying to be like a normal person.
Polite answer. Yeah.
The kind where I'm not trying to get you to hate me. Okay,
Yeah.
But my actual answer is that's all complete nonsense, and it's I don't even know if it's a waste of time if you're just having fun with it.
Yeah.
It's just not real. So
yeah.
If you genuinely believe that things are happening because of the way the planets are arranged, you're out of your mind. But if you just like to, I don't know, collect little trinkets and, talk about your sign in a really, not super serious way, I don't have any problem with that. I could even see myself getting into that for fun. But I feel like most people that are the kinds of people to bring this up and ask me are the people who aren't just doing it for fun. Okay, that's my whole TED talk.
Yeah. Fair enough. I do like to always start off with a random question recently, which is why I did that, just to break that.
That's a good one.
Go
That's
into
a good one, yeah.
something you just aren't expecting because you're I'm going to come here and be on this podcast.
Yeah,
I'm not going to expect to be asked about astrology.
Very good.
Right?
Very good.
Yeah. One of my liberal studies classes was actually related to witchcraft.
Oh, yeah, I heard about that class. Did you do it with someone else I know?
I did it with Ethan, who's one of my roommates.
That's right. Yeah.
But one of the things we learned about was astrology. I was thinking about that the other day. But yeah.
How did you learn about astrology? Did you just learn about what it was, or did you analyze the cultural impact, or?
So we were talking about specifically the 16th and 17th century witchcraft. And we were kind of talking about how the witch trials went and stuff like that over the course of, and why they happened and why people could perceive it that way because there wasn't a lot of scientific backing and stuff like that, right? And then a couple of the classes, one or two, were on astrology and just kind of I don't know, analyzing signs and kind of realizing kind of what we're talking about, planetary alignment and how it can possibly affect certain things. Personally, I don't believe a lot of that, but a lot of people in that class I think actually did. I think there was some people in the front who were really diehard astrologers, but
yeah,
I don't know. Yeah, but also
when that becomes an official branch of science recognized by other scientists, then I might hear it out a little bit. I just don't think it. I don't know. So I don't really think it deserves that kind of spot.
So if one group of people told you, yes, this is real, you'd go for it.
If they were somewhat accredited, yeah. Yeah, I would hear them out, but you're still, I guess that's kind of the whole point of science, right? Is that even if there's some kind of established organization that's telling you stuff, you were still up to your own discretion of how to make decisions and come to conclusions, and a lot of that is how you're raised in critical thinking skills and all of that. So yeah, I guess I've critically thought about this, where it is just a waste of my energy to spend time to it. Yeah,
exactly. Yeah, but that was one of the reasons I thought you would be good for this podcast, because I like to go into random theory discussions or philosophy, and I think just what ifs, and I think you enjoy that as well. So.
Yeah, it's a cool thing because I identify a lot as a scientist more than an engineer, right?
Yes.
And yeah, a big thing about science is how much philosophy comes into it. And I might not know the lingo or the terminology of how to describe some of these philosophical things, but yeah, you can't really have a conversation about science without really butting up against something that we don't really know well, and that's kind of where it becomes philosophy. So that happens a lot. That happens a lot in pop sci. It happens a lot in real science. There's a lot of people who make careers out of philosophical science, or even natural philosophy. So yeah, I don't know. It's a pretty cool intersection that I didn't really know about until I was a bit older. But yeah, I never really like grew up thinking philosophically. I don't know. It's just something to note, I guess.
Yeah, that's fun. I studied philosophy in Greece 2 years ago.
Oh, cool.
That was actually pretty cool because that's like the root of philosophy.
When did you go to Greece?
My freshman summer.
Oh, cool.
So yeah, that was pretty cool. Yeah, and then I got to go again later for Germany.
Where in Greece?
Athens, Delphi, Mycenae, I think.
Very cool.
Is that how you pronounce it? And then,
I'm not sure.
Yeah.
I had a friend who did
Naphtalion was a big one.
Okay,
that
cool.
one I really enjoyed.
Yeah, I had a friend who did like a spring semester study abroad in Thessaloniki, and he loved it.
Yeah.
Loved it there. Yeah.
Yeah, but one of the other reasons I brought up astrology is because I have a challenge for you for this episode.
Okay.
Which is something unique. You're the first one to ever get a challenge.
Okay. I'll be setting the bar really low for the next person.
Yeah. So your challenge is, you don't know what the title of this episode is, but I do. So you have to guess what the title of the episode is by the end of the episode. So I'll give you a couple of guesses. If you can't get it, I'll give you a couple of hints. Okay. And you got to figure out what it is. But it's something kind of related to astrology and electricity. That's all I got to give you.
Okay. Am I allowed to ask for hints at set points throughout the episode?
Yeah, you can do that if you want.
Okay, so is it going to... Can I ask for my first hint right now then?
Yeah.
Is it like a play on words or a pun?
Kind of. It kind of is kind of a play off of a Clash Royale term. And then also electricity.
Okay, that's awkward because
yeah.
I know Clash of Clans.
Yeah.
I've never played Clash Royale.
Yeah.
Yeah. You downloaded it on my phone, but I never actually played it.
Yeah.
Speaking of which, do you have club meetings tonight?
Yes.
You do? Okay.
Probably. Yeah. That's another thing that we kind of talk about a bit as well, is both Gavin and I are part of the 49er rocketry team, and we also go to the Charlotte Rocketry Club meetings.
What do we do at the club meetings?
We kind of...
I think that's a good place to start off, right?
Yeah. We go there ideally to be able to help them out with their design and stuff like that if they have questions and things along those lines. A lot of the time, the club has their own agenda, so we're able to kind of have fun on the side.
Yeah. Or in the back.
Or in the back. But yeah, it's a good time. Speaking of one of the things that we did recently, we recently completed Secret Santa.
Yeah, that's right. Sort of like the first 49er rocketry team internal event of this year anyway. As I think previous teams have done a Secret Santa before, but it was just kind of I don't know, maybe some kind of last minute thing. This was a formal invitation event. Yeah, it was pretty cool. Are you asking me, by the way, about what it was like to organize that? Because that's kind of where I was about.
Yes, that was where I was going to go.
We can cut that later. So okay, so I was doom scrolling, probably on my couch at home, as one does, right? And I came across the perfect gift for a very special person.
Yeah.
We don't need to describe in great detail what the gift is, but it's some kind of plastic mug, and it happens to have a handle on it. It's extremely ergonomic. We'll call it an extremely ergonomic mug, but it's made of plastic. And it was a viral internet sensation for a few weeks. And I thought it was the perfect gift for one of our established colleagues, I guess.
Yeah, you don't really know how to describe him sometimes, right?
Yeah, he's kind of like a unique character in all trades. He really is.
I love how just the way to describe him is just usually his name.
Yeah, that's right. We make up a lot of words that just replace the first letter of his name. Exactly. A lot of inside jokes with this very special person. I can make a soccer reference right now. I don't think it would land very well. Anyway, so the entire Secret Santa was inspired by getting this one gift for this one person. And it was received very well. He ended up loving it, so it was all worth it. But yeah, we designed a mathematically optimized social dynamics algorithm to assign the weight of who's giving the gift and who's receiving the gift. So it was a simple 2-parameter model where we just tried to get a high score based on like making links between people who I perceive to be good at giving gifts and people I perceive that it would be fun to give a gift from. Wait, you know what I mean, right? It's like a two-way street. Everyone was assigned two numbers, and what we got was
several.
Yeah. A couple of them were. A couple of them performed. Like most of them performed to my expectations. Overall, it went like pretty much how I expected it to. Really, a couple of people I'm particularly disappointed in. You know who you are. You did good though, because I gave you a tough one.
Because he's been a more recent addition to the team, so that was something to kind of
but
figure
you did
out
good.
as well.
You did good.
But agreed. In terms of other things, I guess with you personally, kind of getting to more professional stuff. I noticed on your LinkedIn it said that you were, I scoped you out.
Okay, yeah. I don't know that that's ever happened before. Someone told me that they've looked at my LinkedIn.
Yeah, I do my research. But it said that you were interested in eventually maybe pursuing a PhD in geometric control of mechanical and aerospace systems. Is that still the case?
I really left it all out there, right? I didn't give you much to work with, but that's pretty accurate. I think that actually, ironically, I have changed.
Yes, and that's
changed it. That's funny. Okay, because that's so random. I rarely go on LinkedIn. It's mostly just to like accept people's friend requests. Whenever someone's like, "Hey, I posted something. Can you go write a comment?" That's something I take a lot of pride in. It's my ability to write a really fake, formal, congratulations kind of comment, right? It's kind of all fun and games for me. Anyway, Yeah, I want to do a PhD at the next level, which is like really crazy, because I'm a bit older than the average senior, not by
Ancient.
much. Yeah.
Fossilized.
My birth year doesn't start with a 19, but it's pretty close. So, not to say that I'm like really old or whatever, and I'm still gonna be young for a little while longer, but it's hard to say why. There's like a lot of things that
kind of shaped what you want to do.
Yeah, so I used to be a music major.
Yeah,
I used to be a musician, way in another life beforehand, and it's just to me anyways ironic that a lot of the things that attracted me so much about my desired career in music are very similar to
what you wanted.
What I need a PhD for, right? So, I don't know how much detail I really want to give with music. Basically, it was just like at music school, I really fell in love with the process of just like sitting alone in a practice room and getting really, really good at something and finding all these little meticulous details. Yeah. And it's kind of analogous to sitting, like spending time with myself, just studying, doing practice problems. And ultimately, this is what I think it's good to, how do I want to describe this? I don't know. This is something I don't think about a lot, right? It's like, why do I want to do the PhD? I don't know.
Exactly.
It's just something I want to do, and I feel like there's a couple similarities based on other stuff that I've wanted to do in the past.
Do you think it's because like you want to have like more time in school, understanding the process more, or like you just want like more time to research?
Yeah, to be completely honest with you, the math is beautiful. It really is. It's so my signals and systems professor was the one who like put me into this specific area of control theory. And I've just been hooked since. And I've kind of like known for a little while, like this is what I want to do.
Yeah.
But I've just like never had the avenue to like start working in that research field, like at this school specifically. And that's like one of the reasons why I'm considering switching to your department for a master's is, because there is a professor at this school that does this research. But it doesn't exist in the electrical department at this moment, which is rather a shame. Mm-hmm.
Yeah, because I would think controls is more electrically focused, but I guess it's
it's one of those disciplines that overlaps a lot
with and aerospace too.
Yes, right.
Of course.
There's control literally everywhere you look around, from thermostats to everything that happens in your little computers, right? Controls are everywhere, but my specific interests of controls are the big stuff, controlling like the really big, in my specific case, I want to work on satellites.
Big machines, yeah.
Yeah, I want to work on satellites. And geometric control specifically is one of the frameworks that makes like control problems solvable. There are some limitations that other frameworks that have in satellite control specifically. I don't really know what all that looks like yet. This is all I know. It's like the qualitative words of it. But
yeah, no, I got you.
Yeah, PhD for me next. That's cool. I should learn how to like talk about it a little better, right?
I think based on what I get, because I get what you're saying. I think in essence, like you really like the process of a thing and like the math and like kind of how that ties in to be able to control like big machines or elements. I think that generally speaking.
Yeah, I think it's pretty lucky that
what you're interested
in. The area of interest has a practical application, because I don't think that's necessarily one of like one of the driving motivators is like for me anyway is like the practical side of engineering, which is ironic because that's I guess kind of what it's supposed to be, right?
Is,
yeah. So it's a little lucky that I found this area of like math that does have a profound application in like a growing field. Like we need like there are companies putting satellites like by the dozen each year into orbit. I don't know if that's true. Maybe fact check me on that. But we have a lot of satellites in orbit, and then who knows what kind of knowledge of keeping satellites in orbit applies to sending satellites to other planets. And, there's just so many
different nuances.
Yeah, so many exciting areas of application in the aerospace industry. So, yeah.
Okay.
And I feel like at least getting to be around aerospace-minded like people on rocketry. It's really like narrowed my scope into kind of wanting to go into aerospace myself. Yeah, despite not really having much background in that at all. Like I've got the physics side, sure, and I understand all the mechanics and stuff, but I've never actually like thought, oh, let's go down aerospace applications. And I think it's pretty cool now because I wouldn't have been able to tell you that 6 months ago.
Yeah. And that's what I think is really cool because like as you've said, like we don't really have like an aerospace focus here in terms of like degree work. It's building up, but like it's not there.
Yeah,
so like
there soon.
But yeah, but I think
one day, yeah.
But I think the really cool thing is like it's just a bunch of people who are passionate about this who got together, formed the club, and then and turned the team and other things. So.
Yeah, I gotta say it'll be a shame one day when they eventually add the aerospace program, like an aerospace major to our school. It'll be a shame because then we don't have like the 49er rocketry flex that we did it with a bunch of mechanical and electricals. Yeah. I mean, they're still like, aerospace is kind of what a lot of people would consider, and I would probably say the same, is like very mechanically focused, right? Yeah.
But interesting.
Yeah, I have a friend who does aerospace, or he graduated from Virginia Tech, and he said that, a lot of the aerospace graduates can go do something mechanical.
Cool. Yeah, and then also, I didn't say this earlier, but you can also feel free to ask me questions if you so feel like it throughout the podcast, but I'll ask you one right now, which is, what is the biggest nerd fact you think you learned from your degree?
Oh, dear. Where do I begin? Do you have one? I'll throw it right back at you while I have time to think.
Okay.
I should have a lot, but it's just hard to think of one on the moment.
On the spot. Yeah. On the spot, yeah. Fair enough, honestly. I guess one of them is just like, I guess kind of the precision you need with machine shop. I don't know, this sounds kind of like niche, but like I just think it's crazy that we can get down to like a thou or like smaller amounts than that, and we need like these precise tools that you literally have to take the time to create, because one of the things we actually do in machine shop is we create like I'm forgetting the name of it, but you essentially make this tool. I think it's literally called a tool that you have to like cut at the parts, like you put it in a lathe, and then it spins around, and then we'll cut your part, right? But we actually make it from like, because you get given a block, and then you have to figure out how to.
Okay, so you're making the tools.
Yes.
Okay.
Like,
yeah.
At least for the first class, and it's not.
Okay.
It's like a basic tool, but like you actually
Sure.
you take a block, you literally have to figure out how to precisely make it into a thing, so you can so that you can cut down another thing.
Yeah.
Like, but you have to think about like, oh, is this hardness able to cut this hardness? Is this distance able to cut this distance? I don't know. That just is something that I always thought was interesting to me. And like how much precision goes into like machinery.
Yeah, that is pretty cool. This might not be like the nerdiest fun fact that I learned, but like going off of this precision field, there's now a whole field of mechanical engineering that is dedicated to refining certain precisions. Okay, I just thought of one. I'll finish my thought and then I've got one. So like where did precision first come from? Right.
The dictionary.
Right. Yeah. Yeah. John Precision, the inventor of the. But it's like to create precision, you need something that is either flat or square, something that has already been rated
measured
to a certain tolerance, right?
Yeah.
So where was the first like flat surface from? Like, do you have a guess? Because it's not super intuitive, and it's probably not enough to just like wave my hands.
The Earth.
Yeah, right.
None.
The Earth's a pretty flat surface. Yeah.
Yeah.
I thought you said don't talk about politics.
That's not
really very political. Well, no.
Yeah, no, but
it's a religion to
I don't
some,
know.
I guess. But again, we're not supposed to talk about that. I digress.
Yeah.
Yeah, so it has something to do with like if you imagine taking two, roughly is a bad word, somewhat flat rocks, and if you were to rub them together, you would take material off of both referenced to each other. So over time, as you're sliding these, rocks or stones or plates across each other, they would become flat on that, like, plane. Yeah. But they wouldn't be level if you put them on the ground. So that's one place you can get a flat surface from, but it's not level and it's not square. So you can look this up later, of course. Of course. But they're one of the first techniques for ever getting like a real flat and level surface involves 3 of these stone shapes, and like rubbing 2 of them together.
See kind of thing?
Yeah, so it's like one of them is used as the reference.
Yeah.
And then it's like take this one and the reference, rub them together, put this one back, and then another somewhat flat stone. And then over a long time, I really don't understand
Is
why
that kind of
works.
like how we, because I think maybe that's kind of like, well, I mean, at least what we attempt when we do like sanding and polishing and stuff like that, right? At least, because at least we go like this way and then we go this way. And then, like,
Yeah, I wonder.
yeah, I don't know.
I'm not really sure. Yeah, it's not very
at least in
intuitive,
one of our
but-
classes we do that.
Yeah.
Not every. Usually, when you sand, though, you want to sand in the same direction.
Yeah.
For the most part. But.
Okay, so I've got an electrical nerdy fact for you. Are you familiar with Moore's law?
No. Oh
Yeah.
wait, I know Moore's circle though.
So Moore's law is back when I believe it was. Was it Intel?
The dinosaurs?
Was it Intel or was it IBM? Either way, it was before either you or I were born. The people that were making the first transistors and the first computers. When the transistor first came out, how there's like 4 billion transistors, billions and billions of little transistors. These are little electric switches in your computers, right? Specifically in your CPU. There's billions of these things now. They're so freaking tiny, okay? So Moore's law was a prediction from way long ago that said that the size of the transistor will half every, 10 years or something like that? I'm forgetting the exact numbers, but the fascinating part about it is that for a long time, like, this prediction was pretty freaking accurate, where this dude, Moore, his name, okay, was able to roughly, it wasn't like a perfect halving every 10 years or whatever the ratio is, but qualitatively, as the computers got more powerful, or as the transistors got smaller, they were able to pack more of these things into a computer, and that's what like gives us like this linear processing power increase over time, right? So the fun fact is that Moore's law is reaching a point, or maybe it already has. I think the last time I like looked into this, it had already reached the point where it cannot physically continue to go smaller. The size of the transistor has gotten so freaking small that like it's like comparable to the size of single electrons, where like your quantum effects are going to introduce noise that makes your mathematical operations become unpredictable. So we've almost already completely reduced the size of the transistor to the physical limits at which it can be electrically useful.
Interesting.
I think that's a pretty cool fact that I learned because of this degree, yeah.
What's your take on electrons and like how it powers like electricity and stuff like that? I don't know much about this. I was actually looking into this today.
This is another nerdy fun fact. Okay, so you know how like when you connect like a battery to something to power something, right?
Yeah.
So when like let's say you plug in a fan into the wall, and then you have your negative connected with negative, positive connected with positive, and what you see is current. You know, in an abstract sense, you see current moving through the wire, which is what powers your appliances and your technology and stuff, right? It's and current is usually thought of as these moving electrons, right? It's mathematically defined as the time rate of change, or the time derivative of flowing charges, but electrical power is not like, it's not really, like energy is not transmitted laterally in the direction of wires, okay? And there's this is what electromagnetics is all about, is a lot of the, or most of, all of the energy in circuits is transmitted in the fields around the wires. And it doesn't actually like go through the wires, not the energy.
So it's going around the wires?
The energy is transmitted through the fields, yeah.
Okay.
And yeah, that's another pretty unintuitive thing. Is that electrical energy is carried in the electromagnetic fields around the wires. And because the actual drift distance of electrons is pretty slow. It's certainly slower than like human walking speed. So yeah, if it was like directly proportional to the actual speed of the electrons, electrical energy, we would have found something else to power our appliances at this point. So
that's interesting. Yeah. We're getting about close to our time, so I'm gonna have you do two or three more things. Just real quick.
I forgot to think about the episode
yeah.
long. Oh no.
Yeah. So the episode title is 2 words. Our audience already knows this. First word I've actually got you to say probably like 4 times by now. The last word you have not said, but it is related to magic. So you just take a guess at the first word, and if you're wrong, I'll give you one more guess, and then we'll call it a day. Because okay, this is kind of abstract. So honestly, I'm having you guess from like every single word.
First word is something I've
said 4
times or something like that.
Roughly.
Okay. And the second word is a magic related thing, but I have not said it yet. Okay. Wait, is the first word magic related?
No.
The first one's electricity related, right? Or electrical something.
This is kind of hard, but you're doing a good job here. I'll just go ahead and take a stab at it.
I can't even think of something
related.
funny.
It's related.
Like, yeah, dang, this is tricky.
Yeah, no.
I can't even think of something
I didn't realize how hard this would be until I started the episode.
This is hard.
But yeah, it's related to the atom. It's one of 3 things in the atom.
So we're talking about like some kind of orbital model. So there's like an electron. There's a nucleus.
Boom, you said it.
So electron's the first word.
Yeah.
Yeah. And then some kind of magic word.
Yeah, I'll give you one guess and I'll just let you know. It's a little common.
It
literally is so random. W.
Wizardry?
Yeah. Electron Wizard.
Okay, wizard. Okay. Yeah.
Yeah, I thought
if you had given me a hint and just said LaTeX, I would have been able to get it.
Okay.
Because I call myself the LaTeX Wizard anyway. Okay.
Yeah, because I figured that would be a fun title because I was like, oh, electric
Electron Wizard. I gave you some fun electron facts too.
Yes,
you know?
which is.
I don't think about the electron in my daily life. But,
yeah, but I wanted to see if I could make you talk about it without realizing what the
right.
title was.
Yeah.
So I think I think that was a pretty fun discussion. So that was good. But yeah, one last question I have is, what would you like people to take away most from this conversation?
That I'm looking for suggestions about how to talk about research in a little bit of a better way, because, no one actually wants to hear about what my research is, so I might as well learn how to bring it to a more general audience.
True.
With that.
Sure. I thought it was very interesting. I love talking with you about research and stuff.
Thank you.
But yeah. Okay, well, that's our time for today. Thank you, Gavin, for being on this podcast. Really appreciate it.
Thanks for having me on.
Yeah, be sure to follow at Niner Times Podcast on Instagram and at the.Nazareth for updates on episodes. Thank you for listening. Stay tuned and go Niners.